Hello dear friends, welcome back to my channel. I'm Gerard and I'm here to study math together with you. Right now we're learning about differentiation and we have reached the point where we are going to do the second derivative. So the second derivative is denoted as like this. Remember that the first derivative was just dy by dx, and now we have this power thing. And it can also be denoted like this. If you have a function fx, the first derivative is like this, and the second derivative is just prime 2 prime x. Prime x is the first derivative, 2 prime f is the second derivative. So this is about the denotation, but let's have a look at a graph. So this is t, this is x. X is distance and it's in meter, and here t is in second, right? We have a graph. So if we want to know how x is changing in respect to t, we'll get v, which is the speed. So if we have distance changing like this, we'll get the speed. But if we want to have uh, the speed changing in respect to time, we'll get acceleration. How speed is changing in respect to time. But here we only have the graph for x against t. So x against t gives us this graph, and if we look for the gradient at any curve, at any moment, so we'll get the speed. But what if we just do a second derivative? So that's what we are going to learn. So the first derivative of dy by dx. So we have, for example, an expression x is equal to tx squared plus t, and if we do dx by dt, we'll get speed, right, to t, yeah. And then we have dx, the second d square x divided by dt square gives you 2. So the acceleration is 2, but v is here. The acceleration is changing, as you can see. The gradient is changing, but looks like the acceleration is a constant. So acceleration is a constant means that it's straight. Okay, so that's why we need a second derivative, because sometimes when you differentiate first time, you get um, you know you get a value for you know these are for example speed. So you want to know the speed, it's the rate of something, rate of changing distance. So if you want to have this, we differentiate first time, and second time we get the rate of change of the first thing that we obtain by differentiation. So that was an introduction to second derivative, and it's used in physics to calculate the instantaneous speed, or the average speed, and so on. Instantaneous, I would say, because delta t is very small, or infinitesimally tend to 0, and so therefore it's momentaneous, tenuous, or instantaneous speed. It's not the average speed really, because this is very small. Alright, so let's do some example. So we have y is equal to what? We have y is equal to 4x squared plus 1, 4x square plus 1 the power of 2. We have such a thing, and we need to find dy by dx. We already know what is chain rule. Chain rule is that we call this u, and then we find du by dx, and then we find dy by du. This will be what we want. These two will cancel, we'll obtain dy by dx. And we also can do it in a faster way. We don't have to expand this to do it term by term. We could do it as well, like 4x squared power of 2 plus 2 times 1 times 4x squared plus 1 to the power of, and then we simplify, and then we differentiate this term, this term, this term. We don't want to do all these things because now we're used to differentiation, and we're just going to differentiate like this. We do 2 4x plus 1. This will become power 1 times what is inside. This is 8x. This is 8x, yes. Yeah. So overall we have 16x 4x squared plus 1. What it really is 64, I think. 24, yeah, 64x cube, yeah, plus 16x. And that's the answer for the first derivative, or f prime x, if this was fx. Alright, so let's do the second derivative. So I will erase this, I will erase that. So we keep this as the first derivative, dy by dx, and now we want dy d2y by dx2, and that's going to be just term by term. We differentiate this and then we differentiate this. So 64 times 3, this is 12, 16, we have 192 x the power of 2 plus 16, and that's the second derivative. So that's it. This is how we do a second derivative. We differentiate the first time, and then we differentiate the second time. And first rate, which is the first derivative, can give you, for example, speed, just for you to know why we do this, not just you need to learn differentiation. Second one is acceleration. This is the rate of change of this, and this is the rate of change of distance, for example. Alright, so I hope that you appreciated this video so far. What can we do? What can we do is, I think differentiation so far is just as it is. We learn how to use chain rule, and I'm more interested into learning more rules, because now you are used to all these things. You are used to all these things, really. And let's do further differentiation after this. So this was just an introduction to the second derivative. So see you in a bit. I'll make another video about further differentiation.